because of our slapdash arrangement, what you can't see is you do have a class of students here. And many of us met some of you when we went out to the public safety complex to explore it. And so Leah is going to present our kind of our final set of concepts for you and some ideas. But what I wanted to kind of make clear is that we got a bunch of ideas while we were there. Some of them we rejected. So for example, we spent a long time thinking about a trom wall approach, which is what if we used some glazing to capture solar gain on the southeast facing part of the mostly fire station side, and what would that do? And what, after a bunch of calculation and hemming hawing, we found out it wasn't going to work out very well. So there are a bunch of ideas that we rejected that we are not necessarily bringing up here. The models were built by a bunch of by all the students together, and Leah built kind of the initial component of the model. So this represents a group project, but Leah is going to do the presentation. Claire, I saw you raise your hand.
I wanted to know if we're going to actually get a physical paper report detailing
Yes.
all of your findings. Okay.
So our output, as I think I discussed before, is going to be the following three things. You're going to get a copy of this presentation, which contains kind of the actionable information. You're going to get the spreadsheet model that is the basis of our calculation. So it captures everything. It allows, say, if Eversource wanted to fund some portion of it, they would want this model and they'd give it to their engineers to check to see if they buy it. And then you're going to get a cover memo that basically summarizes what's in the presentation. What we found is in the past when we wrote big elaborate reports is that nobody wanted to read them and they just sat there on a shelf and weren't useful. So this is the new model for what we try to hand off to towns.
Can I just jump in for a second? I just wanted to let everybody know that we have Matthew Mick Teague and Caroline from Eversource here. And so I'm not sure if the people in Gill have met them, but they're the people at Eversource who work on municipal projects in your area. And so they'll be key people to help moving forward with implementation of our recommendations. And we also have Mark Rubinski from the Green Communities Division at the Department of Energy Resources.
Yeah, I think I might have traded a few emails, but it's nice to meet everybody as close as we can to get in person at the moment. I took over for Kim Kiernan in early February or so. So any municipal related projects, reach out to me. And I also invited Caroline, who's on the call. She is a new employee to Eversource. So I just thought it might be good for her to kind of observe and just see how meetings like this go. So I'll make sure everyone has my contact information after the meeting, and please feel free to reach out to me anytime with questions or concerns.
Hi, everybody. I'm Mark Rubinski. I'm the Green Communities Coordinator for Western Mass. I'm keeping my camera off because I have a terrible head cold and I feel awful, but that's the good thing about Zoom. I can still listen to the meeting. I know Gil's done a lot of work and I'm really excited to hear what UMass has come up with. I really look forward to these reports and meetings with UMass. So thank you for inviting me.
Okay. So is anyone else? I think I've met everybody, I think, at some point. And so I think without further ado, I'd like to hand it over to Leah to do the presentation, then we can talk about things and answer questions. So I'm going to share my screen and present a slideshow. Hopefully it actually loads. If it doesn't, then we will be very upset. This happened last time too. Okay, that didn't work. So I am going to try and make,
And that looks fine. It's just not in slideshow mode.
yeah,
but-
that's exactly, that's what we're gonna have to do. And even so, I will hand it over to Leah. There you go.
Hi, everyone. So we have 3 goals here: energy savings, decarbonization, and improved thermal comfort. And you can also kind of think of these goals as benefits. So there's our benefits that can be realized if you implement our suggestions. So there'll be an immediate benefit of improved thermal comfort, short-term benefit of energy savings, and then long-term benefit of decarbonization. So here's kind of an illustration of why we chose to focus on the public safety complex. This graph shows all the municipal buildings in Gill and their energy consumption. It's a bit of a comparison. You can see the Gill Elementary School is the biggest energy user. They already have some energy use reduction plans in the works, but the public safety complex didn't really. So it represented this substantial untapped opportunity to reduce energy use. So here's what we're working with. Challenges are uninsulated concrete masonry unit walls, minimal temperature setback when the building's unoccupied, air leakage, poorly sealed garage doors, which are part of this air leakage problem, inefficient and insufficient welding fume extraction, also no cooling in most of the building. Some strengths that we have to work with is those CMU walls could actually be a benefit if we plan things right. They can be a thermal mass that can absorb heat and kind of smooth out any major temperature fluctuations inside the building. The roofs are actually pretty well insulated, and there's a hydronic heating system, so it uses water as the medium of transporting heat around the building, and water is a more efficient transporter of heat than air is. So here's a summary of our recommendations. Top priority is insulating the walls, which will lead to an energy cost savings of 57% and also enable some other changes. The second recommendation we're making is, once the CMU walls have been insulated, is to adjust the garage temperature set point and set back the thermostat when the building's unoccupied. And this will provide an additional cost savings from 11 to 13%. And this setback is a change that can be made without actually spending money on it. So you start realizing the benefits from that immediately without any payback period. And also insulating the walls will enable switching over to air source heat pumps as a heating and cooling system. Not only will this save on energy costs, but this also solves the problem of lack of cooling. And potential benefits that can be achieved by following these recommendations is energy cost savings from 79 to 81%, 92% reduction in greenhouse gas emissions, and of course, increased thermal comfort. Yay. So our building energy model was developed based on, we developed this heat loss model based on building geometry and known material conditions. So essentially what we did was look through plans and go, okay, what types of assemblies make up this building? What's the R value of each assembly? So what's the rate of heat loss per unit of surface area for each assembly? What proportion of total surface area does this make up? And then we use this to calculate heat loss. And then we calibrated the model based on historical oil use, weather data, and model geometry. The accuracy of this was tested before and after the roof renovation. There was only a 2% deviation. Overall model deviation was around 0.4%. So this graph, each one of these points represents Sorry, just blanking out for a second. Each one of these points represents energy use per day and weather, and basically the closer they get to forming a line instead of being spread out, the more accurate this means that our model was. So some quick insights that we got from the model is that the boiler plant was slightly oversized before roof replacement, and now a single boiler is sufficient. And a buffer tank will be advisable to prevent short cycling and excessive wear and tear if the heat load is reduced. So essentially the size of the boiler plant is determined by the rate at which it needs to supply heat in order to meet heating loads. And once you insulate more, you reduce the rate of heat loss, which leads to a lower heating load, which means the boiler can be smaller. And if it's oversized, you can have issues with short cycling, which, like I mentioned, can cause excessive wear and tear. We also found out that because there's such a tremendous amount of conductive heat loss going on through these CMU walls, air leakage actually is proportionately a pretty small amount of the heat loss. So it's about 3% total. So insulating the walls is really like the big ticket item here when it comes to energy conservation. And here's an illustration of exactly how that plays out. So here's a representation of what each assembly contributes to heat loss before and after the proposed changes. And here's how we recommend doing that. So adding 2x4s on the flat to the wall to create bays to put this foam board insulation in, and then adding a second layer over the top of that and securing it with these furring strips. And then this is, I should have said this at the beginning, but this is exterior insulation. So then any kind of cladding can be applied over that.
Can I just want to point out that the reason we're recommending this particular approach is because it's very constructible, right? You're using common materials, you're using common attachment devices, so tapcons, very simple screw systems to attach to these systems. So the idea is it doesn't take specialized knowledge. It can be done by pretty much any contractor. That's why we're aiming for this approach rather than some other exterior insulation approaches. Sorry.
And it is going to require some specialized detailing around windows and around the edge of the roof, since we're building out the exterior wall to be thicker. You will need to have this kind of extra little bit of drip edge at the edge of the roof to shed water out and away from the surface of the wall. So here, this graph illustrates how insulation will dramatically reduce heat loss during heating season and heat gain during cooling season. This graph represents, this yellow line is heat gain throughout the day, and this blue line is heat loss throughout the day in cooling season. This graph on the left represents what that would look like before insulating, and this graph on the right represents how it would look after. And this is what that actually looks like to scale. So you can see it's a very dramatic reduction in heat gain and heat loss. This kind of squished looking graph over on the right represents what it would look like after insulating to scale. So insulation will make the walls warmer in winter. And this helps with thermal comfort because the temperature that you experience is determined by not just air temperature, but also the mean radiant temperature of whatever objects are around you. So making the walls warmer means air temperature can actually be reduced, but the building occupants will still be experiencing a higher temperature because surfaces around them are warmer. So insulating would allow reducing the garage air temperature from 66 to 63 for an additional 2.5% savings. But you could reduce the temperature and it would still feel like the same temperature because the walls would be warmer. Let's see, these graphs also kind of illustrate temperatures throughout the wall assembly before and after insulating. This little kind of horizontal line represents the air temperature inside. And then, I don't know if everyone can see my cursor right now.
Yeah.
Oh, nice. Yeah, so this point represents the temperature on the inside face of the wall during summer. Here's the temperature on the outside face, and then you can see the temperature drops as you move through the wall assembly. And then similarly in winter, the temperature on the inside face of the wall when it's 12 degrees outside is around 50 degrees without any insulation. And you can see in this diagram, once the insulation is added, it dramatically reduces this range of temperatures that this inside surface of the wall goes through. And here's where things get a little more complicated. Insulation will also allow for deeper thermostat setbacks. Our recommendation is to reduce unoccupied temperature to 55 degrees, and that will give you an additional 11% savings.
So I want to just briefly bring this one up, just because this is an example where we asked, we asked, why don't you have big temperature setbacks? And the answer was basically, I think from John, like we tried that once, but you come in the morning and the walls are so cold that it takes a really long time to get the space up to temperature. So you really couldn't afford a big setback. And so this is an example, whoops, my fault. This is an example of where the insulation allows you to actually have a temperature setback where at the setback temperature, you actually have the same wall temperature as you have during occupied periods now. And so that effect that John was talking about is removed once you do the insulation, and that allows the setbacks. That's the point I wanted to make sure was made. Sorry, Leah, go on.
Oh, thank you. That actually helped. I was about to ask for assistance with explaining this slide. And another change that insulating will enable is decarbonization by switching over to air source heat pumps for heating and cooling. Our recommendation is to install mini split heat pumps for the police and fire offices. And since this 2-boiler system is oversized, to remove one boiler, and in the space where the boiler was removed, install a buffer tank and integrate it with the remaining boiler, and then install air to water heat pumps that are integrated with the existing boiler and the new buffer tank. So basically keeping the same heating distribution system, just having a new way of generating the heat that gets distributed. And also in one step, also solving the problem of not having cooling. And also, since you're switching from a system that uses combustion to create heat to a system that uses electricity, that's in line with decarbonization goals. So how heat pumps work, like I said, they're powered by electricity. Instead of combusting fuel to create heat, basically what they do is move heat from one place to another. And air conditioners, so they're actually similar to air conditioners, only instead of an air conditioner basically takes heat that's inside the house, concentrates it and moves it outside. A heat pump can do both. So it can heat and cool because it has a reversing valve that allows it to switch between heating and cooling modes. They're at least 2 times more efficient than other heaters, and they can provide heat even in very cold weather. So why separate mini splits for office areas? Our main reasoning is that the current distribution in the office areas is inadequate. Our evidence of this was when we went there, they had some space heaters around. And here's actually an infrared photo that we took in one of the offices. I don't know if this looks familiar to anyone.
And you can see how cold that wall is, right? That wall, that's where it's the concrete portion of the wall, is really cold. And that is making it so that the distribution system that exists is insufficient to satisfy the heating demand. Chief Redmond, does that accord with your experience?
Yes, very much so.
Okay.
So yeah, the other problem is that the current distribution system in offices cannot be used for cooling. So many split air source heat pumps will provide cooling and separate offices from the rest of the building. Insulation enables lower water temperatures, which enables air to water heat pumps. So the current design circulating water temperature is 180 degrees Fahrenheit. And this is basically determined by the size of the distribution, or the size of the heat emitters in the distribution system, and also the hourly heating demand of the space. And insulating will reduce the heat load from the space. So with the same size emitters, you can use lower temperature water and still adequately heat the space. And you can actually bring your water temperature down to 116 degrees. So this enables high efficiency heating with an air to water heat pump that heats water to a lower temperature than boilers. And the thing with heat pumps is the lower temperature, the smaller of a temperature lift they have to do. So basically, the less of a difference there is between the outdoor air temperature and the supply water temperature, the more efficient they are.
Could you go back a couple of slides for a second, please?
Mhm.
So yeah, the office photo. Is that exceptionally cold wall a concrete wall, or is that the section that used to be an overhead door?
That, I believe, is a section that used to be an overhead door, and that as part of the construction, there is the lower portion of it, right, where you see the blue, is concrete. And I do have an outdoor photo of that, but yeah, that's basically showing as where you're close to the ground, right? If you're building a construction that's, say, a wood construction, typically you want to raise that above so you don't get splash and you don't get the degradation of that wood construction. So where they infilled the former door is what's now kind of a mix of those two types of materials. But it was, the heating system was probably sized as though it was all an insulated wall. And that's one reason why it's insufficient. Is that
Thank
good
you.
enough? So yeah, Lee is about to hit this kind of a complex graph.
Oh boy, this is where things get mathematical. So we have several things going on here. On this axis, we have outdoor air temperature, and these gray bars represent hours in a year that the outdoor air is at this temperature. The higher the bar, the more, basically the more hours per year outdoor air is at this temperature. So you can see the vast majority of hours in the year during heat that are heating hours. Thank you. The vast majority of heating hours in the year take place above 31 degrees. And as you can see, as you go below 31 degrees, the amount of hours drops off pretty sharply. This red line represents the coefficient of performance of a heat pump, and how, as the temperature decreases, this coefficient of performance goes down. And then this yellow line represents the supply water temperature. So as this temperature goes down, as the outdoor air temperature goes down, the supply water temperature that's needed to satisfy heating loads goes up. And these two blue lines, the intersection is the average seasonal efficiency of this heat pump system. So now we're getting even more mathematical. This blue line represents the capacity of the heat pump to extract heat from the outdoor air. And you can see how that goes down as the outdoor air temperature decreases. And this black line represents, as the temperature decreases, the heating load increases. And eventually, at some point, the need to add heat into the space will surpass the ability of the heat pump to add heat into the space. And that's where the boiler comes in as a backup.
So I'll just explain. The reason we're showing you this is that we've specified a heat pump for you. And rather than having you buy a third heat pump to make up for this 11% of the hours, we're suggesting you buy just the two that would satisfy, almost 90% of your heating season, and then use your existing perfectly good boiler to make up the difference rather than kind of over specify to deal with this small portion of time.
So here's essentially exactly what Ben just said. Two heat pumps, and you keep one of the boilers that you already have just for backup and for those peak load days and times. And the heat pump can also provide cooling in the garage bays with chilled water and the existing fan coil distribution system. And here's a summary of our recommendations and benefits in terms of energy savings and in terms of greenhouse gas emissions reductions. And over here on the right-hand side of this table, you can see what their payback period would be. And as you can see, this wall insulation really is like the key to making everything else work, because once you do that, you can do these temperature adjustments and setbacks, which have no cost to implement, but they do have additional savings, and they'll reduce the payback period from 9 years down to 8. And we do have a couple additional recommendations, but they're kind of lower priority. One of them is improved garage doors and seals. So the current garage doors are poorly air sealed and they have less insulation than what's commonly available. So they're R5 as opposed to R17. Replacing them with better insulated doors at the end of their life could reduce energy use by 7%. Does have kind of a long payback period of 24 to 35 years. But there is an intermediate and shorter term solution, which is improved air sealing around the doors. And this detail is an example of how that would be implemented. And the typical payback period for that would only be 2.5 years. And another suggestion is improved welding fume extraction. So spot fume extraction more rapidly removes fumes than generalized ventilation, which is the current method. And this mobile welding fume extractor could be moved to wherever welding takes place within the DPW shop. It offsets the need to run a generalized large exhaust fan, which anytime you're exhausting a bunch of conditioned air, you're basically like wasting whatever energy you use to heat or cool that air. Energy savings undetermined, but not negligible for the reason I just mentioned. And it will have a great benefit on air quality and also benefit employee health. And the estimated cost for this is around $5,000 to $11,000, depending on the size of the equipment that you get. And that's all.
Thank you, Leo.
Thank you, everyone who listened.
So I think what I want to do is I'm going to keep the share up so we can go back to slides as needed. But I just want to open it up for any questions or comments. And yeah, Claire.
So this is fabulous. It's really encompassing, it deals with at all different levels of that building use. So one question that I had was the outside insulation. The detailing for the roof part made sense. How do you deal with the ground interface? And do you need to actually excavate some below ground surface? Or how do we deal with, snow and ice and water and those issues?
This simply would be gapped above the ground at like an inch. You're not interacting with the ground at all. It's just the wall. We're not going to address the perimeter heat loss from the slab. It's just not, it's not practical to address it. So we won't try.
Okay, that makes sense. That's great. And I like how you also use the existing boiler that we have to make up for that 11% of really cold days peak load. Because it's already there, we might as well. And at a certain point when energy becomes so expensive, then we can add in the third heat pump. Is that all we would need? Is the third one then? Or is it a more complicated calculation?
No. Yeah, you could add yet another air to water heat pump. There's some plumbing involved, to connect everything, balancing and so forth. But first of all, how people manage their space often does change. So this is something where I would rather see you try this level first, or any one of these measures, and kind of work your way through it. And you're going to find differences in performance from what we anticipated. Just even if we were 100% right, even our model is perfect, your operation will change once you've started to operate with these different systems. Very often we find that the heat pump capacity goes a lot larger than what the manufacturer is willing to warrant. And so you may find that you don't need any. We're talking about a fairly small use for the boiler. I will say these are excellent boilers. If I wasn't so sad about fuel oil, I would say I'm very happy that you have such excellent boilers. You have one more boiler than you actually need, right? This already, with the roof insulation that you already put in, you only need one of those. And so if the town has a need for a different fuel oil boiler in the short term, you could actually pilfer it from the DPW.
Can that boiler be retrofitted to use waste oil?
It can, but that's not going to be, you don't want to do it.
Okay.
Let's just say you don't want to do that.
And that's still burning fossil fuels, so.
It is, yeah. And it's as a fuel oil boiler, it's really good. So I saw John unmuted himself, and then Janet.
Yeah, I don't know if everybody, excuse me, everybody knows it, but our boilers here at the building, only one boiler runs. The other boiler is basically just for a backup. It's if it gets, I don't know what the temperature is outside, but if it gets below freezing, I think that will kick on also, but 99% of the time, it's just the one boiler that runs.
Yeah, and currently with that old situation where sometimes when it got very cold, that other boiler would kick on, I bet that was before the re-roof.
Yeah.
With the new roof, your heat loss is such that actually that you only need the one
Definitely.
boiler.
And I just had another quick question, if I may.
Yeah.
I know you mentioned the other two offices in the building. If you're gonna do two of them, why wouldn't you do the highway departments at the same time?
Oh, because it has fan coils. So any place where you have a fan coil unit that's providing heating, then it can also use the heating or cooling, the circulating water to also provide heating and cooling. Whereas if you only have fin tubes, then you can't do cooling because you would condense water onto it.
I don't understand what you mean. All we have in our site is electric baseboard heat. Is that what you're talking about?
Okay, that's something where I did not get my my specs correctly.
Yeah. My office and break room is the same as the police station and fire station.
Okay, well, in that case, you would treat them the same.
Okay.
And so it's possible, actually, you know what, I was using diagrams off the plans, so I may have mislabeled whose office was what, but I still called them offices. So I think we may actually be right in terms of what systems go in and what size they are based on the size of the space.
Okay.
But maybe I didn't label them correctly.
I just want to say also, excellent presentation. Very interesting.
Janet.
So I had similar thoughts as John, and I just wanted to say, you can take those things up in the ceiling and make them cool too. I mean, that's really impressive.
Mhm.
And I wondered why you didn't do the highway department's office, and it wasn't really clear. I was in the building, and I remember, where the fire department's office is and where the police department's is. And from what you just said now, do I understand that the highway department is in the same room with the big table and the chairs where the fire department is?
I mean, I would let the people who occupy that space answer it. So,
Well,
here-
if
here are
that's
the-
true, they do have one of those fan coil heaters in there. And would that be enough by itself? Or maybe,
yes. So any of these things were sized originally to satisfy the heating load with 180-degree water and the current envelope. If you change the envelope as dramatically as we're talking about, then you can use the chilled water for cooling and the heated water for heating with the same fan coil. You're going to have to retrofit it with a drip pan. It's going to have to collect the condensate and run it to somewhere, but that's fairly inexpensive and a lot less expensive than adding a whole new air source heat pump just for that space. So this is one of the limitations of our process, which is we went there for an hour. We ran around, we took a bunch of pictures, we talked to a bunch of people, and we definitely are going to have made mistakes in terms of what heating system or what distribution system was in what office, or in this case, maybe mislabeling an office. But for the entire building and for its basic components, offices and garage space, I think we got that right, even if we got, so we may be off on some of the labeling, if that makes sense.
well, basically,
Oh, you're muted.
I'm dyslexic. Basically, you're saying that the highway department will get cooled, that building, that room there.
Yes, any place that is an office and has fin tube, like baseboard distribution, that's not able to do cooling. And so you would want to use an air-to-air heat pump for those spaces so that they can get cooling, they can get heating, and they're independent from the temperatures being required for the garages.
Okay, thank you.
So Mark, then Ray, then the chief.
Great presentation. I think I missed it. What was the domestic hot water for the building?
It's very small. We didn't consider
Separate
it.
unit?
Right now, I don't even remember. We looked at it. It was just inexpensive. I think it was electric resistance heating. If they did the system we're recommending, I would recommend eliminating or preheating the water for that electric resistance heater off of the buffer tank that we're recommending.
And could you do that in the summertime too, when you're mostly cooling?
That would be different. In that situation, what we'd actually do is we'd actually be able to use the heat pumps in reverse to heat another space. The problem with spending any money on that is that their use of hot water is very, very low.
Yeah.
So it's stuff you could do, but it just doesn't add up to a big part of what they're doing in that building.
Okay. And then for the idea of keeping the boiler, I guess this might be a question for Eversource. Would that reduce the incentive? Because I thought that in order to fully recognize the incentive, you had to completely get off of fossil fuels for it.
I guess, can you guys hear me now?
Yes.
Hey, so this is Matt McTeague with Eversource. It does not reduce the prescriptive incentive of 2,500 per ton if you keep the oil as backup right now is my current understanding. I'm just looking on the forms to double check that.
Okay, thanks, Matt.
Okay. Do you have any other thoughts, Mark?
No, this was great. Thank you.
Okay.
I love the external masonry insulation. Yeah, we're gonna need a lot more of that.
Yeah, we do. And I think this system is one that is time tested, easy for anybody to do, and replicable with a bunch of different types of rigid materials.
Mhm.
So yeah, Ray.
I'm going to echo all of the other statements of really great job. This some good ideas, well thought out. The analysis seems pretty sound from what I can see. First question I'm going to throw to Mark and Matt. Are you seeing incentible projects with what's been presented, especially that key project number 1 of insulating the outside wall? Is this something we could do a Green Communities grant and also get Eversource funding for?
Sure, I can speak towards the Eversource incentives, and then Mark can jump in and talk about Green Communities. First of all, Mark, you were asking about if you leave the oil furnace in place. That I believe that's on the residential side, that there is a slight reduction in incentive if you leave your oil or gas furnace in place. On the commercial or municipal side, there's no reduction on the incentive. It's $2,500 per ton of heat pump. And then you asked if there was incentives available. There absolutely is. For the insulation portion, we do a custom incentive based on that, which we take UMass's calculations, have it double checked by an engineer on our team, and then base the incentive off of the expected amount of therm saved basically on the project. And then, as I mentioned, the heat pumps it's called a prescriptive rebate. So basically, you guys would have them get installed, fill out a form, mail in the form, and hopefully within a couple of weeks, you should have that incentive check back in hand for $2,500 per ton. And yeah, that's kind of where I see the incentives on there. There is also the possibility of you guys were talking about the water heaters. There are heat pump water heaters available, and there is a whether or not, if that's something you guys want to do, there is a point of sale rebate available for those. So basically, if you go to a distributor or your contractor purchase them, there's an instant rebate basically that comes off the air source heat pumps. But
I mean, again, what I'd say about the water heater is based on kind of discussions with John and just kind of like my sense from how they're using water, essentially a little bit of hand washing, not many showers being taken, any of that. It probably isn't the best measure for them. I'd almost be inclined to do a point of use electric water heater at the sink and lose the storage loss.
Yeah,
for the amount of heat that or hot water they're using.
Yeah, it's hard to make a recommendation without seeing how much you guys water use. I probably the best case right now, just leave in place whatever you have, and then maybe when it breaks down at some point in the future, maybe look at an air source heat pump or something along those lines, or a point of use as Ben was recommending.
Yeah, the reason I brought that up, and I think the point of use might be a good idea for this application, but I've seen in other applications where they've put in air source heat pumps or air to water, and they left the oil boiler in place, and the oil boiler is still running all year long just to heat the
Yeah.
small amount of hot water that never gets used by anybody in the building anyways. So, you just have to think about these things holistically when you're thinking about all the projects. Ray, to your point about green communities, the proof is always in the savings. So it's hard for me to say. I didn't see any projects that are like ineligible to be applied for, but given that these are competitive grants and you're competing against all of the other green communities, and we're trying to maximize the amount of energy savings and greenhouse gas emissions, sometimes you don't know until you've put it all into the spreadsheet, and you've kind of see where everything falls into place against the other projects.
So Ben and Leah, for the cost of the installation work, do you know if the labor portion of that included prevailing wage?
Yes, I used prevailing wage in my estimate.
Great.
But to be honest, I used an old spreadsheet, so it may not be quite up to date.
But you're likely in like within horseshoes and hand grenades range.
That's the
certainly
point, yeah.
better than not considering it at all.
Yeah.
On the getting rid of the second boiler. So on the one hand, I like the idea. I think that it's a new enough boiler that it might make an excellent backup boiler for the Riverside building, which has probably a 50-year-old boiler that I would be scared to turn on right now. But I wonder, does the safety complex's existing backup generator have the capacity to run basically an electrified heating system in a multi-day power outage?
So what I'd say is let's think of it this way. We've got two boilers. One of them we don't need now. Okay, so that's the first part. Now we're saying do the insulation and maybe some air source heat pumps for the offices, right? So we didn't get everything, but we got some of everything. We still have that one boiler heating the garages, basically. Let's imagine a situation where the power goes out and your generator is not enough. And then we've also added these air source heat pumps, but we still have that boiler sitting there doing nothing, but it's still there. The power goes out. If your generator is enough to run the pumps for the fuel oil boiler during the power outage, that existing boiler can heat not only the garages, but it can also use the old distribution system that's still there to heat the offices. So that one boiler has the capacity to do everything it needs to, and as long as there's the electric power available to run the pumps, it can do your backup heating in the case of a power outage. So you still, if you remove that one boiler, you're not really affecting the redundancy. In fact, what you've done is you've increased the redundancy, because now we've got air source heat pumps doing most of the work. And if they go out, you still have your old boiler. And now you've put your other pretty nice boiler in this Riverside building, for example, if the sizing is correct, and I don't know anything about the Riverside building. And so it's also got a high quality boiler.
Okay. Has anything changed in rigid foam technology to make it so the ants don't like it as much?
I am so impressed that you know this. That is amazing. So
got exterior pink insulation on the foundation of my house.
yes.
Or what's left of the insulation.
So the key thing is that ants don't eat it. They like to move through it. It's chewable. So although the pictures that I showed that pink insulation, that's just because that was some pictures from another project that I had pictures of. But we're actually recommending polyisocyanurate foam board. Or a combination of polyiso, for example, and rock wool. And rock wool is very unpleasant for ants. They don't really move through it. But so I wouldn't recommend the extruded polystyrene. That's the XPS. That's both has high global warming potential, high embodied energy, and isn't as good as polyiso from a thermal point of view. But it's really, really common. And if it's in ground contact, then termites and ants like to move through it. But if there's a gap, like that 1-inch gap that we're talking about, and it doesn't get wet and stay wet, if there's not a wet edge to it, then it doesn't become an attractant for those ants. So the basic story is you keep it dry and you keep it drained, and then it's not going to be an ant highway, which I honestly, any below ground XPS becomes an ant highway or ground contact.
So just one last comment, the idea that mobile spot fume extractor, I like that. I think, John, if we can find specs on that, maybe for next year's Maya safety grant or incentive grant. That's all I got. Great job, guys.
Thanks.
Thank you.
Chief, you've been waiting a long time.
Yep, well, I got a couple questions. On the east side of our building, you remember that installation way up on top?
Mhm.
The old-fashioned fiberglass?
Mhm.
Would your outside insulation make that the same as the lower brick walls? Or you still gotta do something with the old foam fiberglass up on top?
No.
They cross the highway and fire.
Yeah, no, we're not really treating that. So that's the roof, right? We're basically talking about the roof, or we're talking about those little short vertical
The little
walls.
short pieces.
Yeah. If I had all the budget in the world, I would definitely specify a measure for those short walls. But when we looked at the benefit, we weren't able to make it be particularly cost effective. So, so what I would say is that's kind of like a next step. This vertical insulation on the walls actually wouldn't affect those. They are insulated, not great.
Yeah,
And so it's one of those things where it's a judgment call. And if there were the budget for it, it's like the garage doors. I would love to see those changed out to be better. But it was harder to justify it from a cost perspective. It doesn't mean it shouldn't be pursued.
okay. Just as far as energy saving,
Mhm.
our hose dryer. The last thing you said as you walked out the door was maybe a humidistat would work better than a timer. Have you done any research on that, or?
No, that's just basically looking at the principle of the thing. What we want is if the exiting air is dry enough, then we know that it's not extracting any more water from the hoses. They must be dry. So it could shut itself off instead of running it by time. Also meaning maybe it runs longer because you get the hoses to the dryness that you actually want. And I haven't studied it, I haven't looked into it, but we're talking about electric resistance heating on that hose dryer. Now, okay, so this is something I did not talk to the class about at all, but in my fantasy world, you take that hose dryer and you have an inlet air that's actually solar heated. There's basically a perforated metal facing south as the air is getting drawn into that thing and then exhausted. If you're drawing it in through a south-facing absorber, a ventilated absorber, you heat up the air, and now you could use solar heat to dry your hoses without exposing them. Like I know a lot of fire stations, they'll lay their hoses out on the apron or something and try to dry them in the sun. and they're getting some solar degradation and all that stuff. So you keep them in the cabinet, but you still use solar energy. I'd love to do that, but I did not spec that out for you guys. If that's something you were actually interested in, just for fun, I would love to experiment with you.
Yeah, it's been a bone of contention for quite a while now, but we having a hard time finding an electrician that will come up and put a switch in for us, a timer, I should say.
So I would definitely consider a dehumidistat. It can be, this runs into a regular, is it 240 volt?
Yeah.
Yeah.
I think it's a 30 amp, 20 amp.
Yeah.
up there.
So you can get a relay. Again, you'd have to find an electrician who would install a dehumidistat relay where the dehumidistat sensor is in the exhaust duct.
Okay.
That's what I would do.
And the next two things are kind of related, are infamous compressor and three-phase system. Is that anything we can do with this particular grant, or, I mean, scope of work, or?
So it's not something that we looked at.
Okay,
So yeah, the short answer is we weren't looking at that particular problem.
Keith, I'll jump in real quick. We do have incentives available for checking compressor leaks, and we can pay for a study for that, and then that's something maybe after this meeting you can reach out to me and we can talk about that offline.
well, when this compressor starts up, the whole building goes dim.
No, I think that's more of an electric supply issue as opposed to savings. But if there are air leaks, that is something we could definitely help you out with.
We try to keep the air leaks at a minimum. The last thing is, since our Eversource is here, John can pipe in on this, but supposedly there is in the works an upgraded lighting project that's supposed to be done here that seems maybe got lost in the shuffle, or.
Yeah, I was looking it up. I see there's we call it expedited lighting. There's one proposed for the town hall, and then one also proposed for the safety complex. As I took it over from Kim Kiernan about a month ago, we're working with Energy Resources to get the numbers out to you guys. So you guys should see those hopefully in the next week or two. Energy Resources should be sending those over.
John, wasn't that already approved, you said, or Ray?
The gentleman that came and did the walk around and did my office and Chief Redmond's office said after he was here that day, they should be back within 30 days and start the work. That was in the fall. I haven't heard another word.
Yeah, I think there might have been a little bit of disconnect. The end of the year gets really busy for us, but they are working their way through the system, and I'll have Energy Resources reach out to you guys within the next week about these projects.
Okay.
I'll just leave it at that.
So is that Gary that's at Energy Resources that you're working with?
There's
Derek,
probably.
okay.
Derek.
I'll get in touch with Derek then.
Okay.
So Lauren?
Yeah, Matthew, you mentioned the compressed air study. I'm wondering if there's a minimum size compressor that you would do that type of study for?
Off the top of my head, I don't know the answer to that, Lauren. I don't think it would be cost effective to do it on a very small compressor. But what that exact size is, I don't know off the top of my head.
Okay. And then also, Matthew, I was wondering if you could talk a little bit more about next steps. We can send you the calculations, but can you help connect the town with contractors who could do this type of insulation work, or what should they do next?
Yeah, absolutely. We have a list of utility approved municipal vendors, one of them being Energy Resources, you guys working with on the lighting program. If you like working with them, you guys can work with them on this project, or reach out to one of the other vendors on our list that I can provide you guys with. Or if you guys have a vendor in mind that you've worked with in the past that you want to continue working with, Eversource is completely vendor neutral. The only reason we recommend using one of the vendors that's on the municipally approved list is that through Green Communities, the Chapter 25A, if the project is under $100,000 and you use a utility approved vendor, you don't have to go out to bid on the projects. So, but that said, we are vendor neutral. You guys can make the decision on which vendor to use completely on your own, or you can use one of the utility recommended vendors.
Thanks. Good job, Leah.
Yeah. Oh, yeah. And I meant to say, Leah, great presentation. That was a lot better than a lot of the contractors who've been doing this for years. It was very thorough. Great presentation. So.
Oh, thank you.
I was just curious, is there something that covers up the insulation out there? Any sort
Yeah,
of
whatever.
siding or,
Cladding of your choice.
so it's
Um,
$7,000 plus to side the whole building?
Nope, we included that. No, you could go with an expensive cladding. I chose the cheapest metal cladding. Because I figured it's DPW. But yeah, I mean, if you went to something like fiber cement, which you could have, there could be some good reasons to do that. That's gonna almost double your cost.
Thank you.
Any other questions or comments from anyone in our group?
Throw one more question.
Okay.
The overhead door air sealing, is any overhead door manufacturer, or not manufacturer, but like service company likely to do that? Or is that more specialized work?
I think some of them will only sell the product that goes with their door, the seal that matches their doors. And then there are other companies that just sell seals. Like you find the seals that match the spec for your door, and you redo, basically you take off the old seals and put in new seals. So I wouldn't be surprised if pretty much the typical manufacturers reps around here also rep a range of seals.
Sure. Thank you.
I had a question. I'm sorry if I missed it. I had to take a call. On the offices that get the air-to-air pumps, how many heads do they get? Is it just one per office or each room, or how does that work out?
Well, so my recollection of the police station in particular is you've got kind of your office that you're in now, what looks like, I don't know, a booking area or like a front desk sort of area. And then that's connected to a larger kind of a meeting room and I guess a booking area off to the corner. So the portion that is kind of open plan, that would share its own head. Your office having a door that closes would get its own head. And then so this gets down to kind of details of design. Because you've got a suspended ceiling, it may make sense to use a short ducted unit in this case to get a single unit that ducts both to that conference room sort of area and that entry area with the front desk, because it's really small. So rather than buying two units and having them both be oversized, you get the one unit and you do a short duct to capture both areas.
Thank you. Great presentation.
Thanks.
Thank you.
So if there's nothing else, I'll say that we will send you this material. I don't know, should we send it directly to Claire, or is there someone else that we should be sending it to? I can also just send it to the whole group.
I'd like a copy too, if possible.
Oh, of course, Mark. Yeah. So
I can distribute to the Gill Town folks.
Okay. Great.
And in your report, will you have, is it detailed enough that we can share it with contractors and that they will be able to provide bids and quotes? Or will we need more detail?
We have the details in the spreadsheet.
Okay.
And then you've seen the detail in the presentation. So that's to the components. I would think that any contractor who wanted to do a bid would actually want to come out themselves
Yeah.
and size each of the aspects themselves.
Okay. And can you add the hose dryer information about that? Whatever that device is called?
Sure, the dehumidistat. Yeah, we'll put that
Okay.
just in the cover memo as like additional thoughts.
Okay.
Okay.
I just want to encourage those of you in Gill to stay in touch with us. I mean, if there are questions when contractors come out, or you get quotes and you want to have Ben take a look, we're happy to help move this forward.
Yeah, and Claire, after this meeting's over, I'll send out my contact information to everyone in the meeting. Make sure you guys have it. And whenever you guys have questions or you want to move forward with this project, please get me involved, reach out. I'm happy to help. That's my position, is to work with just municipal customers in Western Mass to move these kind of projects forward. So.
Okay. And I just realized, is Mark still on the call from Green Communities?
Yeah, I'm here.
So do you know what the fall schedule is for that grant cycle?
Yeah, the fall competitive grant application is due October 7th.
Okay. Good. We've got some
And you
leads.
don't have any, Gill doesn't have any grants right now, right?
None outstanding. No.
I think so.
Yeah. So we have our annual report completed and we can just then submit for the new competitive grant cycle.
Yeah, your annual report's completely approved.
Okay, super. Thank you.
Okay, well, thank you all very much for joining us and for your really good questions and corrections. And we will send all that stuff out. And I want to thank you again, Leah, for taking on the lion's share of the work. And I'll call the meeting adjourned. Bye, everyone.
Thanks, everyone.
Thank you.
Thank you.